Hello viewers, this is another round of lectures in Turning Point Tutorials. We are here to take a mathematics lecture, and we've always had good times, and today I believe it's going to be another good time. Today, check your board, we have logarithm. Logarithm is one of the aspects in mathematics that we need to tackle in preparation for WAEC or JAM, NECO, GC, what have you. Okay. Now, for those persons that took logarithm in your XS1, you were told to calculate logarithm using numbers less than 1 and numbers greater than 1. Okay, and you have to use your anti-logarithm table where you have your what have you, your 1, you do some 2, 23 under this, different this, and all that. Okay, and then but today we'll be looking at logarithm, without table, using the laws of logarithm. So today I'm looking at the introduction. I'll give the introduction, I'll take some questions to welcome you into this class. And then when I meet you next time, we'll now discuss further. So let's look at the laws of logarithm. The laws, quickly. The laws of logarithm. Now please understand something, that logarithm is actually a direct opposite of indices. So if you have a good knowledge of indices, this will really help. Alright? So let's quickly go. Law number 1. If you have a logarithm, let's say logarithm A, okay, plus you have logarithm B, what do you say? Now when you add two logarithms together, of course, especially when they are of the same base, you know quite well that if I don't have a base here, then you should consider it as base 10. But for now, let's remove this base. So consider it as base 10, so they are of the same base. So because it add, then you will take one of the logarithm symbol, and then you multiply together. You have log AB. Number 2, if you have log A minus log B, okay, so when you subtract the logarithm of the same base, what it's saying is this, that this first logarithm should be divided by the second. So that's log A divided by B. Beautiful? Beautiful. Okay. Then we want to look at another principle. Log 1 to any base at all, let's just put base A this time around. Log 1 to any base is 0. I will stop here and I'll make progress. When I say log 1 to any base is 0, I will just show you something shortly. When we say log 1 to any base is 0, what do I mean? Now look at this very well. For those who have done indices, you will understand that you have log 1 base A equal to 0, then you are saying A, the base, raised to power 0, equal to the logarithm itself 1. A raised to power 0 equal to the logarithm itself 1. So what do you see? If the base A is raised to the power 0 equal to 1, then what can you say about this? It's not true, according to indices, that anything raised to power 0 is 1. That tells you that we have converted this logarithm to indices. So that settles that case for us. Now come back quickly. So we can say number 4, that a logarithm to its own base will give you 1. Any logarithm to its own base. So log A base A is 1. Log B base B is 1. Log 10 base 10 is 1. Log 2 base 2 is 1. So please accept that. Okay. Then number 5, we can also say this, that log A, let me just take raised to power C. Okay? Or let me make it very clear by putting figures. Okay, so log A raised to power 2 can be rewritten, meaning that when logarithm has a power, the power of the logarithm goes back to multiply the logarithm. And in some cases, they might give you the logarithm itself, there's already the power at the back, and of course you may have need to take it back as a power. So log A raised to power 2 becomes 2 log 2 log A, meaning that the power of the logarithm is coming back to multiply the logarithm. This is what you have, number 6. Let's assume we have a base log A base B raised to power 3. This time around now, it's not the logarithm that carries the power now, but now the base. But sometimes you can have a situation where logarithm has power, base has power. But that's not where I'm going. Talking about a case where the base has the power. Let me break it down a little bit. Okay, so log A base B raised to power 3. Now the power of the base, we still go back to multiply the logarithm. What are you going to get? In this case, when the power of the base is going back, it's going to take the reciprocal, meaning that 3 is about 1, so it's going to take 1 over 3. It turns upside down as it goes back. So what do you have? 3 come back, that's 1 over 3 instead of 3 over 1. So 1 over 3 log A base B. This is what you have. Number 7. Let's what called inverse logarithm. If I give you log A base B, and mind you, everything here is over 1. So if I'm trying to take reciprocal of it, that means 1 over this, is the base becomes a logarithm, while logarithm becomes a base. So go up, I'll have 1 over log, so writing A base B, you write B base A. And very importantly, there's one I want to add, which is log base number 8 now, which is I call it change of base. Change of base. Meaning that if I have log A base B and I want to change the base, I want to change the base from base B to something else, let us say base X. What happens to the B? If I remove this B now, I want to put base X. So I'm going to have log A base B now. I'll have equal to log A base X. So where would the B go to? The B forms a new logarithm, taking the new base to divide the old logarithm. Okay, so log A base B is same as log A base S all over log B. Now base 99 logarithm base X now. So this is what we call change of base. Questions? In logarithm, you do simplification in logarithm, and after you have simplified, we will step up to looking at the logarithmic equation, that's equation in logarithm. And after that, we'll go into substitution in logarithm, where you need to substitute some certain logarithm into expressions and solve. Today, I'll give you questions to welcome you and drive you into simplification, and then I'll come back for miscellaneous cases or advanced questions. Alright? If I give you log 16 base 2, what can you do about that? Very simple. Let's start from somewhere. Log number 1 now, log 16 base 2. This is just this is for you. We're starting from scratch. Log 16 base 2, as simple as it is, very simple. Ask yourself, you have to look at the relationship between the base and the logarithm. Check between base and logarithm. Is there anything common between the base and logarithm? 16 and 2. You know index in your GSS class. Index. If I say, what's the index of 9? You're going to tell me 3 times 3. And 3 times 3 means 3 power 2. So when I tell you what's the index of 49, you're going to tell me 7 times 7. Of course, you know 7 squared. So index of 49 is 7 squared. Index of 9 is 3 squared. Now what's the index of 16? It has to form. Of course, very careful. We give you 4 times 4. That'll give you what? 4 squared. But then, because you have base 2, you're very careful. You reduce it now to what? To index of 2 times 2, that's 4 times 2, that's 8 times 2, that's 16, that's the 3 power what? 4. So you don't use 4 squared now because you cannot achieve your result. So you come back to this and then use the right index working with the given base. So I'll put my 16 in base 2. So that gives me log 2 raised to the power of 4 base 2. Of course, you know, I told you come back. So this, that Lo5 says that if you have a logarithm that has a power, it goes back to multiply the logarithm. So that means 4 is coming back to multiply. So when 4 multiply, it gives you 4 log 2 base 2. That takes you back again to this principle that says that when the logarithm to its own base gives you 1. I said earlier before that log 2 base 2 is 1. So what you have now is simply say 4 times 1, which gives you 4. This is just question number 1. But if I give you a question like this, say log 1 over 2 base 2. Let's go to example 2. Let's take some few examples as for a start. Okay, now log 2, or let's say log 1 over 2 base 2. You're wondering, what should I do? Don't forget in indices that we said that 1 over x should give you same as x minus 1. So in the same vein, you come to this side, you see that this is what? Log 2 raised to the power minus 1 base 2. Of course, this seems and this seems the same. So minus 1 is the power, it comes back to give you minus 1 log 2 base 2, which you get as minus 1 because this is already what? 1. So minus 1 times 1 gives you 1. Okay, this is just for beginners. Now, can I travel with you now with some advanced questions? Let's see what we can get. Now, 6 log 8 base 4 minus 32 base 4. Look at this quickly. Question number 3. 6 log 8 base 4 minus 32 base 4. Here goes this question. Yeah, this may want to put you off as to how do I go about this. Of course, you know, this 6 here is now is the power you have on the logarithm 8. So you take it back. When you take it back, what do you have? Solution to the question. Take it back. You have log 8 raised to the power of 6 base 4. Don't be afraid to do that. Minus log 32, okay, base 4. The next to do is this. Don't forget that both of them carry the logarithm. And when you travel back, you discover that the law says that when you subtract the logarithm, you add. So this logarithm is being divided by this logarithm. So that's why I say that log A minus log B is log A divided by B. So that if I have this now, that means I'm having log 8 into bracket now, log 4, base 4, 8 raised to the power 6 all over 32. Very cool. This 8 raised to the power 6 will give a large figure. So what do? Simple. 32 can be placed in index of 2. So let's place 8 now. So 8 takes what? 8 itself is simple as 2 raised to the power 3. And don't forget that there's a power 6. So that 2 power 3 is going to make 6. That produces 2 power 18. Okay? So put it there for now. Then just let me take it down a little bit. So log 2 raised to the power of 3, 6 all over 2 raised to the power 2 raised to the power, okay, that's 2 raised to the power 5. Okay, this is what you have. Then don't forget that you have base 4. Continue. This gives you 2 power 16, 18. That's log 2 raised to the power 18 all over 2 raised to the power 5 base 4. Okay. Can you come to this direction? Let's see. Let's make progress from here. Okay. Please travel from that place. Now we have log. Before I do anything, let's just check it out. You know, in indices, when you divide, this actually indices now. You're having 2 raised to the power 18 all over 2 raised to the power 5. You know that when you divide log in indices, this 5 goes up to become minus 5. You're going to get 218 minus 5. But let's assume you have a minus sign here, for example, minus 5, for example. When it goes up, so I have minus half plus. That's the trick. So you just say, take this is base 2, base 2, carry 5 up, and you have, what have you now? Minus 5, which gives you 2 raised to the power of 13. So we are working with this now. So logarithm 2 raised to the power of what? 13. Check it up there. Base 4. This is what we have. Okay? So let's continue from here now. What do you have? Then check this quickly. How can I resolve this logarithm and this base and make it the same? Don't forget that base 4 can also take index of 2. So that gives you log 2 raised to the power of 13. Then put the 4 in index, you will get 2 raised to the power of 2. What did I say earlier? I said that when a logarithm has a power, it goes back to become what? 2 log A. I also said that when the base has a power, I give an example, it will go back and take a reciprocal, which is 1 over 3 log A base B. Let's apply this principle here now. Okay, so we have the power of the logarithm coming back as 13 multiplied the power of the base coming back, taking reciprocal 1 over 2. You have log 2 base 2. And log 2 base 2 is 1. So you have all you have now is just 13 times 1 over 2. Okay, so 2 here 1, 2 to this, that's 6 all over 1 over 2. Okay, let me help you. This is as what? 13 over 2. This is as what? 6 all over 1 over 2. This is the application of this question. See, I have to take it carefully so we don't have issues right here. Okay, let me see if I can take decimals. Some person have issue with decimals. Alright, now go with me now to example. Example, what now? That should be example 4. Okay, let's take decimal now. Let's say 0.001 base 10. If you have something like this, let me remove this. Question 4. You have log express or simplify, whatever. 0.001 base 10. How do you do this? Of course, I told you that 0.001 is same thing as you say, put decimal 1 here, sorry, your 1 here, and 000 here. All of this, what do you have? 1 over 1000. Thank you. So that means this value is simply now saying log 1 over 1000. Okay? That's 30 base 10. And don't forget what I said earlier, that 1 over s is as s minus 1. So that means 1 over 1000 is as 1000 minus 1. Okay? And don't forget that 1000 is now what? 10 power 3. Which multiply minus 1 to give you 10 raised to power minus 3. Alright? So let's apply this quickly and see what we have. So that means everything I have here should be log 1000 minus 1 base 10, which gives you log what? 10 raised to power what? Minus 3 base 10. Of course, you know that this will come back to multiply the logarithm. That gives you what? Minus 3 log 10 base 10. And now 10 base 10 is what? 1. 1 times minus 3 gives you minus 3. This is resolution to this question. Let's see if we can advance to other bigger issues. Okay, this is just to welcome you. Let me take an advanced question before I think of rounding off. Let me go with some roots. Now, log root 20 base 10 plus log 5 base 10. Let's see what we can do from here. Question 5. Log root 20 base 10 plus log 5 base 10. And what's the next thing there? Minus log root 5. Minus log root 5. When I say a question like this, I'm very settled in my heart because the question is already arranged. Why did I say so? Because the positive sign came before the negative sign, so it's arranged. What do you do from here? Don't forget you have base 10 here also. So you just go with 1. It's a very simple thing now. Take 1 logarithm, log base 10, open the bracket. Everything's all base 10. So this, don't forget that in logarithm, when you have addition, you multiply. So this multiply this because of the addition, divided by this because of the subtraction. So you say root 20 multiplied by 5 divided by root 5. Okay, that's all right. And then for those of you that you have done solid, you know quite well that 20 can get a factor as 5 times 4, of which you know 4 itself is a perfect square, and the square root of 4 is 2. That comes out to give you 2 root 5. Okay, so we can simplify this to give you what now? So that root 20 is written as what? 2 root 5, okay, multiplied by 5 all over root 5 base 10. This is what you have now. Let's go with the brackets still. Okay? The next thing to do is, you understand something now? Let me bring it up. 2 root 5 times 5 over root 5. I will cancel out. I have the freedom to do that. But on one condition, because I'm having a multiplication sign here. It is completely wrong in mathematics for you to do this. 2 root 5 plus 5 over root 5. Or you say 2 root 5 minus 5 over root 5. You don't have the right to cancel. No, no. You don't have the right to cancel. No, no. Why? Because of the plus sign and the minus sign. But for the principle of multiplication, you can do that. Alright? So you can easily divide when you have multiplication up and down. So the multiplication sign now gives you the freedom to cancel off. Then 2 multiply 5 gives you 10. So you're going to have log 10 base 10. Of course, you know when logarithm has its own base, you're going to rest the case as 1. Alright, I think I will love to round off by dropping some few questions with you. And I believe added value. Please stay put and solve this question for me. What if you go for exam and a simple question is given to you? Mind you, what we are doing here is just an introduction. I'm coming for stronger questions than this. Now, help yourself and see if you can solve these few questions now. I will give you simplify log 27 raised to the power 1 over 3. Okay. All over log 81. You can solve this for yourself. Okay. And then let me give you evaluate log 0.125 base 2. Okay, and then let me give you a simpler question here. Okay, let's try this now. This might be advanced for you, but let me give you log 30 over 10 over 16 rather base 10 minus 2 log 5 over 9 base 10 plus summation plus log 400 over 243 base 10. Let me help you here. For this one, try to solve it and see if your answer will be 1. Because it's an advanced question. For this ones, they're very simple. Okay, so I just did introduction now to logarithm. This is actually one of the simplest questions you can ever find. But we are going up. We're going to meet in the next class. If you've added value, I would like you to stay put, do my assignments. I will meet in the next class. Thank you very much.